Now that we've had a good preview of simulations, let's take a look at the full 7-step simulation process. So we're going to look at a simulation, which is basically a sequence of random outcomes that models a situation. So there are 7 steps for us to create this, and I apologize that the writing is so small, but I wanted to put this all on one page so that you could maybe take a screenshot or something like that to use as a helpful tool moving forward. So step 1 is to identify the component to be repeated. And what that means is every time you choose a random number or numbers, what does it simulate you doing in real life? So it should be some verb or action. So every time I choose a number, it represents what? Step 2, how will I model the outcome? This means assign your random numbers based on the percentages given to you in the question. So we've already practiced that in our last video, but we'll get some more practice in the upcoming questions that we'll do together. Step 3, there is so much going on, so usually that's worth more points, so make sure you consider the following questions. How many digits will you consider at a time, 1 or 2? So we talked about when we can use 1 and when we can use 2, but hopefully we'll talk about that a little bit more as we do some more practice together. What happens if you get a repeated outcome? If I get the number 15 and then I get the number 15 again, can I use it twice? Good rule of thumb here is if the number 15 represents a specific individual, then I can't use it again because I've already chosen that individual. If the number 15 just represents the 20% of potatoes that are bad, then I can use the number again. Next, do I have any digits or pairs of digits that are unassigned? So when I'm assigning my numbers in step 2, did I leave out any numbers on purpose just because it made sense to do so? In which case, make sure that you include that in your little write-up. What will I record for each random number or numbers? So that should go back to whatever the component to be repeated is. If my component to be repeated is, say, choosing a CD from a group of CDs, then what I'm recording is that CD good or bad? So I'm thinking about the question that my online students will be doing for their question this week. When is the trial over? So how do I know when to stop checking CDs, or how do I know when to stop looking at the colors of M&Ms? And then how many times will I repeat the trial? And that last one should be given to you in the question, or you should be able to figure it out based on how many rows of a random number table you are given. So a lot going on in 3, so please make sure that you don't just overlook that one. A lot of people do. 4 says state clearly what the response variable is, and essentially it's saying, why are we running the simulation? What question was asked that we are trying to answer using the simulation? That is the response variable. Then we're going to run several trials. So we're going to show the step-by-step outcome, which means the result for each digit or pair of digits, as well as the overall outcome. So when I was looking at M&Ms, I recorded blue, green, yellow, blue, blue, etc. That's the step-by-step. The overall outcome would be, say, it took 10 M&Ms to get one of each color, etc. Analyze the response variable. If your response variable is finding the number of something, then I'm going to have to analyze it, which means if I was looking at how many M&Ms I needed to get one of each color, my first trial I got 10, the second trial I got 14, the next trial I got 12, then I would take 10 plus 12 plus 14 and divide by 3 for 3 trials, and to find the average number of M&Ms I needed to get one of each color. And then lastly, of course, we're going to state our conclusion, and our conclusion should always go back to number 4, which is what the response variable was. So I'm trying to answer the question that I had been asked to answer, or that I used a simulation to answer. If your result from number 6, the average, is a decimal, it's okay to leave that answer as a decimal because it's more precise than rounding to a whole number. So now that we have sort of our basis, and maybe it doesn't make sense yet, and that's okay, I'm going to take you through a simulation step by step by step on the next slide. Before I do that, I just want to point out that these 4 steps are really all together in one step in a paragraph form. So this is basically steps 1 through 4. Here's my step-by-step how I'm going to do the simulation. Step 5 and 6 is running the simulation and finding the results. So that's usually in one step. And then step 7 is the conclusion. What did we learn? So let's take a look at a simulation together. And we're going to go step by step through this, so I didn't number them for you, but I've separated all of the steps out. But keep in mind that when you do this yourself, these will all be in a paragraph form. So I've separated them out so you kind of see exactly what should be included for each step. But the question itself says a couple plans to have children until they have a girl or until they have 4 children. What are the chances the couple will have a girl? So before I even get started, what is important to understand is I am trying to answer this question. So a lot of people struggle because they're not answering the question that's being asked. So let's look at each of the parts of this simulation. First is the component to be repeated. Now this means every time I choose a random number, what does it represent happening in real life? And of course, in this simulation, every random number I have would be the couple having a baby. So that is the component, because this is a verb. This is an action. The couple is having a baby. Also, just to point out, this is one of those simulations where it's obvious why I wouldn't be able to do this in real life, because then that's just a lot of children. Step 2, explain how you will model the outcome. Again, this is where you will assign your values. So did they give me percentages in the question? No, but we can all assume here that 50% of the time the child will be a girl and 50% of the time a boy. Obviously, there are some people who disagree with that, but let's just stick with that to make it simple. And then I can say I can model this with 1 digit. So yes, I could use 2 digits. I could use 00 to 49, 50 to 99. That would work just fine. I have decided to use 1 digit, and so again I'm using 0, 1, 2, 3, 4, which is 5 digits, and then 5, 6, 7, 8, 9, which is 5 digits, and we can see that 5 out of 10 digits is 50%. And so it's really important that these percentages are reflected in the values that I've chosen. Explain how you'll simulate the trial. This is the very involved one where I have to include a lot of things. So I'm going to say I'm going to start at the first value of the random number table provided and record the gender of the child based on my number assignments, which of course I've already given in this step. If the child is a girl, the simulation stops. If the child is a boy, the simulation continues until either a girl is born or 4 children, I guess, are born. Either way. I will then record whether the couple had a girl. I will repeat this process for 10 trials. So again, this sentence right here throws a lot of people because they're saying, well, why are you doing that? Well, what am I trying to answer? I'm trying to answer, is the couple going to have a girl? So after I record all of the genders of their children, I'm then going to record whether or not they had a girl. And I will repeat this process for 10 trials. Now, how did I know 10? Because I know how many rows that I've given you. When you do this in your own practice, you will know how many trials. And then lastly, state what the response variable is. Again, the response variable is the probability that the couple has a girl. So I just used this sentence exactly. I changed chances to probability because it's more mathematical. So now let's take a look at how I would actually run the simulation. So this would be like step 5. I'm trying to run the trials. And just as a reminder, I'm going to write at the top of the screen that we said 0 to 4 would be a boy and 5 through 9 would be a girl. So what I'm doing is I'm looking at the digit 0, and 0 is a boy, so notice in my table I've recorded boy. And then I look at 1, and 1 is a boy, and so notice I've recorded boy. And then I look at 5, and 5 is a girl, and remember when I wrote how I was going to run my simulation, the simulation stops when I get to a girl or 4 babies. So this simulation has stopped. Notice I'm not writing anything here because the couple has stopped having children. They got the girl that they wanted. Now notice what's happening in this column. I am recording whether or not the couple had a girl because that's what I'm trying to get to at the end of the simulation. So I put yes, they had a girl. Then I'm going on to my next trial. Now notice my next trial starts on the next random number table row. So 0, which is boy, 2, which is boy, 9, girl. Yes, the couple had a girl. And I continue. I'm not going to go through each of those step by step, but I continue and continue and continue. And I see here and here the couple had 4 boys. And so out of my 10 trials, 8 yeses and 2 no's out of the 10. So when I get to step 6 that says analyze the response variable, I'm recording how many times out of 10 did the couple have a girl, which was 8 out of 10 times, which is 80%. Then I'm going to use that in my conclusion. According to my simulation, the couple is 80% likely to have a girl. Or you could say, according to my simulation, the probability the couple will have a girl is 80%. That is all 7 steps of this simulation. Now notice I've given you the exact same question again, just as I did with M&Ms, just to illustrate to you that there's no one exact right way to set this up. So let's say, and again notice I'm writing this in paragraph form for you just so you have that extra practice to see what it would look like in paragraph form. But let's say instead of using 0 through 4 and 5 through 9, what if I said let 0 represent boy and 1 represent girl. Does that still work? Well, I'm only using 2 digits, so this is 1 out of 2 digits, which is 50%. And this is 1 out of 2 digits, which is 50%. But then what happens with 2 through 9? Then I have to ignore them. So everything else about the simulation will be the same, except for step 2, where I talk about what I'm going to do with the values. So notice in paragraph form, the component to be repeated is the couple having a baby. Since 50% of the time a child will be a girl and 50% a boy, I can model this with 1 digit. Let 0 represent the couple having a boy and 1 represent the couple having a girl. Ignore the values 2 through 9. Start at the first value of the random number table and record the gender of the child. If the child is a girl, the simulation stops, so I put 1 next to it just to remember that that's what means girl, but you don't need to. If the child is a boy, the simulation continues until either a girl is born or 4 boys are born. I will repeat this process for 10 trials. The response variable is the probability the couple will have a girl. So that should look very familiar to the example that we just did, because the only thing I changed is the number assignments. Now notice when I actually perform my simulation, in this case because I'm using 0 for boy and 1 for girl and the rest of them are being ignored, so I'm just going to put an X for I didn't record anything for that one. So here 0 would be boy, 1 would be girl, I'm done because that's 2 children and one of them was a girl. Then I go to the next one. 0 is boy, 2 is girl, I'm sorry, 2 is ignored. I got confused myself for a second. I apologize. 2 is ignored, so notice I recorded an X. 9 is ignored, so I recorded an X. 7 is ignored, so I recorded an X. 2 is ignored, so I recorded an X. 5 is ignored. 6 is ignored. And then I get a 1. And so now this is still only the second child, and it's a girl, so I stop. And then I keep going and keep going. So here I had a girl. Here I had boy, girl. So yes, I had a girl. Here I had boy, boy, girl. And so yes, I had a girl. And basically I just keep continuing and continuing. And so if you'll notice, unless I've made an error somewhere, my result each of the 10 times was yes, the couple had a girl. So the response variable is 10 out of 10, which is 100%. So according to my simulation, it's 100% likely the couple will have a girl.